Alright guys, I'm just going to run through this revision test that we did just to make sure you can identify where you made any mistakes, but hopefully you've already done that. We'll see how we go. Let's see how long it takes us. So the first one here, we got 2x by x, that's going to be 2x squared plus 6x. When I expand the next bit, minus 3 by x is minus 3x, and negative 3 by negative 2 is positive 6. So that's 2x squared plus 3x plus 6 must be D. Here we're just going to substitute in values. Negative 5 squared is going to be 25 plus 2 by negative 2 by 3. So 2 by 2 by 3 is 12, and it was a negative in there. So 25 minus 13, minus 12. Sorry, I'm jumping to the answer. 25 minus 12 is 13. Right now, the next one here, we've got to get them with a common denominator. These fractions, you can only add or subtract fractions that have common denominators. So the first one gets multiplied by x plus 3 over x plus 3. So my denominator there is x minus 6, x plus 3. And the second fraction that needs to get multiplied by x minus 6 on the top and bottom. So this is plus 2, x minus 6. And then we just simply expand. So I've got 5x plus 2x, it's going to be 7x. 15 minus 12 is 3. So 7x plus 3 over those other two brackets. You've already found it, haven't you? A. Inequality, shaded in circle, means that, what does a shaded in circle mean? It means that, I'm just trying to find where my cursor is, it means that it includes the point. An open circle means that it doesn't include that point. So I want x is greater than or equal to 7, less than 9, must be E. Flying through these, which does not lie on the line, this is just a matter of testing them. Put in the x value, see if it equals a y value. Negative 2 by 4, negative 2 by 4, that didn't help. Negative 2 by 4 is negative 8, plus 5 is negative 3. That's right, negative 2. Negative 2 by negative 2 is 4. 4 and 5 is 9, that one's right. Let's put in 3. Negative 2 by 3 is 6. So negative 6 plus 5 should be negative 1. They've got the answer of 1. We found the one that doesn't work. If you want to, you can go ahead and check. Oh, it's doing all sorts of crazy things on me tonight. Go ahead and check and make sure the other two work, but we've already found one, we're confident with it. Horizontal line, going through this point, all horizontal lines have an equation, y equals a number. So in this case, the y coordinate is 8, so this must be a, y equals 8. There we go, done. The rule for the following linear relation, all we've got to do is identify the gradient, and we're done, aren't we? Once we've got the gradient, we're as good as there. So here we go. It's got a y coordinate of 3, so I'm going down 3, so that's negative 3. Across 4, because I go from negative 4 to 0, so negative 3 over 4x, y equals mx plus c, so it's negative 3 over 4x, plus the y-intercept, well in this case the y-intercept 0, so there's nothing else to do, we're done. Gradient of a line, rise over run, difference in y-coordinates, so negative 4 and 5, that's a difference of 9. Difference in x-coordinates, so how did I get that? I went 5 minus negative 4, so I'm going to do negative 2 minus 1. Negative 3, 9 divided by negative 3, negative 3. Here we go again. What do we need for an equation of a line? We need a gradient. So the gradient equals rise over run. Here I've gone from the y-coordinate of negative 2 up to a y-coordinate of negative 1. So I've gone up 1. I've gone from an x-coordinate of 0 to an x-coordinate of 1. So I've gone across 1. So the gradient is 1 over 1, which is 1. Y-intercept. They've given it to us. Negative 2. So y is going to equal 1 times x, which we just write as x, minus 2. Problem solved. Midpoint. What is the midpoint? It's the average of all the points on that line, isn't it? Or on the line segment. So how do I find an average? Add the points together and divide by how many there are. So here I'm going to have 5 plus negative 1 divided by 2, and the y-coordinates, negative 2 plus negative 4 divided by 2. You could do this one in your head. I'd be happy with that. 5 minus 1 is 4. 4 divided by 2 is 2. Negative 2 plus negative 4 is negative 6 divided by 2 is negative 3. Problem solved. Answer B. Moving on. Just join your like terms together here. 2a squared b's plus another one. Just written in the other order, but it's still a squared b. So that's 3a squared b's altogether. Here I've got negative 8ab squared plus another 3, negative 5ab squared. That's all 4 terms done. Easy as you like. Multiplication, number by number, letter by letter. 3 4s are 12, c squared by c gives me c cubed, d by d, d squared. Next one here, what can I cancel in when I've got fractions? I can cancel common factors. This is factorised, that's factorised, so I can cancel. E can cancel with E. They go into each other once. I've got one F on the bottom and two F's on the top, so that F can cancel with one of those. -6 on top, 2 on the bottom, 2 goes in the 2 once, and in the -6, -3 times. So I've got -3F, and I've only got 1 in the denominator, so that's my answer, -3F. Here we go. I can't cancel anything because that top expression is not factorised. So let's factorise it because I've told you 1,000 million times, give or take 1,000 million, that you can only cancel common factors. So here I've gone ahead and I've factorised it, and I've done that incorrectly, haven't I? Because I was too busy trying to say 1,000 million. So, and that's a billion, isn't it, these days? It used to not be a billion. That's interesting. You can look that up sometime. There we go, though. The 5s are going to cancel. And I'm just left with 2x take 1, because it's going to be 1 times 2x take 1. So it's just 2x take 1. Problem solved. And I said x when I can clearly see it's k. Getting late at night. Just persevere with me, though. We can do this. Even at this hour of the night, we're killing it. Here, common factors. Can't factorise that expression, but 7 goes into 7 once and into 14 twice. 1 times m plus 7 is m plus 7 in the denominator. 2 times m, 2m. Problem solved. Division is multiplication by a reciprocal. Here I'm dividing by a fraction, so I'm going to multiply by the reciprocal. I'm also going to factorise that top term because I know that factorising is going to help when I'm dealing with multiplication or division of fractions. 3n's a common factor. I've got n plus 3 left over. The denominator is just 2n there. Change it to multiplication by the reciprocal. N plus 3 there. Oh, look what can cancel here. N plus 3, n plus 3. That's 1 over 1, isn't it? N on the top and an n on the bottom, they can cancel. So I've got 3 by 4 over 2. Well, 2 goes into 2 once and into 4 twice. So now I've got 3 by 2 is 6. And in the denominator, I've only got 1. So that's the answer, 6. All right, next one here. We've got to get this with a common denominator. The common denominator is going to be 5x. So the first little fraction there needs to be multiplied by x over x. And the second one needs to be multiplied by 5 over 5. 4 times x, top times top, is 4x. Top times top for the second fraction, 2 by 5 is 10. That's it. You could factorise that numerator, but the 2 that's a common factor isn't going to cancel, so you can just as happily leave it like that. Rightio, next one, we're going to write these with a common denominator. You know that 3 and 4 both come to 12, so let's do it. The second one gets multiplied by 4 over 4. First one gets multiplied by 3 over 3. When you're doing this, remember to multiply each term in that numerator by the number that you've chosen to multiply by. So 3 times 2x plus 1 becomes 6x plus 3. 4 times x minus 2 becomes 4x minus 8. We simplify that. 6x and 4x is 10x. 3 minus 8 is minus 5 over 12. Again, 5 is a common factor at the top. It's not going to cancel with 12, so I can leave it there. I'm done. Solve the following equations. Inverse operations, the opposite of getting dressed. It's like getting undressed, getting rid of everything until you just get the x on its own. Whatever's got the least to do with it, you get rid of first. Here, the 3's joined to the x, so I do the opposite of subtracting 4, which is to add 4. Add 4 to each side, and I will have 3x equals 18. Divide each side by 3, and I will have x equals 6. This one here. X plus 5 divided by 2. The 5's got more to do with it than the 2. 2's a separate little section there. X plus 5 is bracketed because it's underneath, it's on top of the vinculum. So multiply by 2, so this is equivalent to x plus 5 equals 14, minus 5 from each side, x equals 9. Next one here, 2 times 3x plus 8 equals 2x. I could expand first, but looking at this, it's already factorised. There's a 2 there and a 2 there. Let's just get rid of those, divide each side by 2. Now I've got 3x plus 8 equals x, so I can subtract x from each side. So I'll have 2x plus 8 equals 0. You've already figured out the answer in your head. 2x is negative 8, x equals negative 4. If we check that, negative 12 plus 8 is negative 4 by 2 is negative 8, and 2 by negative 4 is negative 8. We would have got it right. Here we go, 3 and 2. We've got x's on both sides, and we've got denominators. So let's get rid of those denominators in one fell swoop. I am going to multiply by the lowest common denominator, which is 6, which means on the right-hand side I'm left with 2 times 4x take 3. And on the right-hand side, 2 goes into 6 3 times, so it's 3 times 2x take 1. Now it's just a matter of expanding. 8x take 6 equals 6x take 3. Get all my x's on one side. I'm going to move them to the left. Subtracting 6x from each side will give me 2x. I'm going to add 6 to each side because I don't want that 6 there anymore. So negative 3 plus 6 is 3. And finally divide by 2. X equals 3 over 2. Going pretty well. Let's see how we go. On to the next bit. What's the only thing we need to remember when we're solving inequalities? If you multiply or divide by a negative, the direction of the sign changes, and we remember looking at that in class. Righto, here we go. I could subtract 3. I think I did that when I did it last time. So this time I'm just going to change it. I'm going to multiply everything by 2. It doesn't matter. So I'm going to have 6 minus x is greater than or equal to 14. Multiplied each term by 2, so I subtract 6 from each side. I got negative 6 is greater than or equal to 8. I don't want negative x, I want x, so I could multiply or divide by negative 1. Either way, the direction of the sign changes, and x is less than or equal to negative 8 is the answer that you want. Next one over here, x is on each side, so I'm just going to get them on the side which has the most of them, which is where the 5x is, so I subtract 2x from each side. That means the numbers I want to get rid of, so I add 4 to each side, and I'm going to be left with 9 is less than 5x, take 2x is 3x. Dividing by 3, I've got 3 is less than x, which of course is probably easier if we just say x is greater than 3. But you got it right either way. Either of those will be right, no problems. Graph each of the following linear equations using the given method. Here we've got the y-intercept, gradient and y-intercept. Y-intercept is 4. Gradient, negative 3 over 2. So I've got to go down 3, 1, 2, 3, across 2. There's another point. Now, to draw this line in is a little bit tricky on this because I'm not writing on the screen, I'm writing on a tablet, which is just like a black piece of plastic. It makes it a little bit tricky, but we got it there, that's good enough. Label your equation, y equals negative 3 over 2x plus 4, and we're done. Use the axis intercept, so when I let x equal 0, I'll have negative 4y equals 12, so y-intercept is negative 3. When y equals 0, I'll have 3x equals 12, dividing by 3, x is equal to 4. There's the other point. Join them up with a nice straight line. Write your equation and you're done. 3x take 4y equals 12. Flying through this. Here we go. Find the equation of the straight line. So I need to know the gradient and the y-intercept. So what's our gradient? Rise over run. Well, let's see. I've gone from negative 2 up to 1. That's a rise of 3. What was my run? I went from negative 4 to negative 2. That's a rise of 2. So my gradient is 3 over 2. The y-intercept they haven't given me, I know it's up there, but I don't know what the number is. So how do I figure it out? Well, I write out my equation, y equals 3 over 2x plus c, and I choose to sub in one of the points. I am going to sub in the point negative 2, 1, because I think it's going to be easiest. We'll see. Y equals 1, and that is equal to 3 over 2, x is negative 2, plus c. Multiplying and dividing by 2 cancels, but it's a negative there. So I'm going to have 1 equals negative 3 plus c. Add 3 to each side, 4 equals c. I've got my y-intercept. I have my gradient, so I have my equation. Y equals 3 over 2x plus 4. Done. Nearly there. Find the exact value of the distance. Distance is an application of Pythagoras' theorem. In this case, the distance equals the square root of the difference between the x-coordinate squared, so 3 minus negative 2 squared, plus the difference between the y-coordinate, 6 take 4 squared. Well, that's just 5. 5 squared is 25. 6 minus 4 is 2. 2 squared is 4. 25 plus 4 is root 29. Done. Find the midpoint. We've already done this once, so the midpoint's just the average of the 2 points. Negative 2 and negative 6 is negative 8 divided by 2, which is negative 4. 8 and negative 2 is 6 divided by 2, which is 3. That's how easy it is to find a midpoint. Will the graphs be parallel or not? Well, this one, parallel lines have the same gradient. This one has a gradient equal to 1/4. What's the gradient of the second one? Let's get it in gradient intercept form and find out. So I add x to each side, so 4y equals 8 plus x. It's probably nicer if I write that as x plus 8, because that's in mx plus c form. Finally, I divide by 4, so y equals x divided by 4 plus 2. Well, x divided by 4, that's the same as a quarter times x, isn't it? Look, there's a gradient of a quarter, there's a gradient of a quarter, so therefore they are parallel. And you could write a nice little sentence saying they're parallel because they have the same gradient. Find the equation of a line that is perpendicular to a gradient of negative 3, to this line which has a gradient of negative 3. So the gradient is going to be negative 1. over the one that we're given, which was -3. So the gradient of the new line is going to be m equals 1 over 3. -1 over -3, same as 1/3. The negatives can cancel. Great. Perpendicular to that, so I've got the gradient, so I know that y equals 1/3 x plus c. Sub in the point I know, which is 3, 2. 2 equals 1/3 of 3 plus c. 2 equals 1 plus c, therefore c equals 1. So the equation is y equals 1/3 x plus 1. And we're done. Simultaneous equations using the method of substitution. I'm going to call this first one equation 1 and this second one equation 2. I can't call it the first one again, what a goose. Alright, that's y equals 2x minus 8. So I'm going to say sub, and you could just say equation 2 into equation 1, or you could say y equals 2x minus 8, or just 2x minus 8 for y, any of those things. Substituting this one into the other one, therefore 3x plus 2, and I don't write y, I write what my new expression is for y, which is 2x take 8, equals 19. Expanding this, I'm going to have 3x plus 4x is 7x, take 16, equals 19. Add 16 to each side, 7x equals 35, x equals 5. Sub x equals 5 into one of the original equations. I am going to pick equation 2 because it's already set up for y equals, which is what I'm trying to find now. So therefore, y equals 2 times 5 minus 8. Y is equal to 2. And you can say the simultaneous solution is the 0.52 if you would like. Nick makes $250 an hour for 10 hours worked, so if I divide it by 10, I'll get his hourly wage. That's good because that's what they wanted. It's just $25 per hour. What does that mean if I wanted to write an equation for how much money he earns in a certain number of hours, H, very creatively named? Well, he takes $25 and he multiplies it by the number of hours he works. Pretty easy. How many hours does Nick work for 375? So I'm letting him, his money equal 375. So let his money equal 375. So therefore 375 equals 25 times the number of hours. Dividing by 25, you will have 12, 13, 15 is equal to the number of hours. There you go. Anthony and Brian are selling tickets. I'm going to let A equal Anthony tickets. Anthony's tickets. Sold. And B equal blah, blah, blah. Brian's tickets sold. What do I know? They sold 80 tickets. So therefore, A plus B equaled 80. And I also know Anthony sold 12 more than Brian. So Anthony's number equals Brian's number plus 12. What am I going to do? I'm going to sub that second equation into the first equation. Therefore, instead of A plus B equals 80, I'm going to have B plus 12 plus B equals 80. Subtracting 12 from each side and adding the b's together, I'm going to have 2b equals 68. And dividing by 2, b equals 34. Therefore, A equals 34 plus 12. Using this equation here, A is equal to 46. So you could say something along the lines of Anthony sold 46 tickets and Brian sold 34. You'd be done. Now when we get here, adults and children, I'm going to use little a this time for the number of adult tickets and little c the number of children's tickets. And you could write that down if you had a bit more room. The total number of tickets was 80. So I've got A plus C is equal to 80. The total cost of the tickets is 168. So I must have an equation involving costs. So it's $3 for adults, $2 for children. Oh, okay. So the second equation will be $3 for every adult ticket plus $2 for every child ticket is going to give you your total of 168. Very good. What am I going to do? It says to use the equation by relating the two variables. Solve this pair of equations using the elimination method. Okay, so I'm going to take equation 1 over here, and I'm going to multiply it by 2 so that I can get the coefficient of c to equal 2. So I'm going to have 2a plus 2c equals 160. I'll do my subtraction here. 3a minus 2a is a. 2c minus 2c cancel. 168 minus 160. Oh, the number of adult tickets is 8. Therefore, c is equal to 80 minus 8, which is, of course, 72. There you have it. We're on the home stretch here. Last question. Find the region and intersection of the points of intersection of the 3 lines. I've gone too far there. Y is greater than 0. Oh, we know that y equals 0 anywhere along the x-axis. So if I could draw perfectly straight lines, that would be handy, but on this thing it's particularly hard. There's y equals 0. Now I want it greater than or equal to 0, so I'm only interested in the points where y is greater than 0. So that's up from there, isn't it? All right, the next one, y is less than or equal to negative x plus 7. Well, I got the y-intercept there, so let's put in what we know. Once I can find where my cursor, there it is. There's the y-intercept of 7. And a gradient of negative 1, so it's going to go down through these points here. And if I could draw that perfectly, I will amaze myself. And I know I won't be able to, but we'll just go with what we have. It's a little bit wonky, but you get the idea. We've got to label which one that is. That's y is less than or equal to negative x plus 7. Less than or equal to, let's test our point 0, 0. Is 0 less than or equal to 0 plus 7? Yes, so it's the side I want. So I want to shade the side, including the origin, but I don't shade it yet. I'm just using these little arrows until I'm finished. Otherwise, you end up with shading on shading on shading, and it confuses the heck out of you. The third one, they haven't been as nice, have they? Y minus 2x is less than 4. We've got to rearrange that so y is less than 2x plus 4. Okay, gradient of 4, y-intercept of 4, gradient of 2, up 2 and across 1. Oh, it goes through there, up 2 and across 1. Down 2 and backwards 1, same thing. There we have the line, but what did I need to do for this line? If you look carefully, less than only, isn't it? There's my cursor. It's less than 4. So what do I need to do? I just need to go through and dash that line to make sure that we show that it was a y minus 2x is less than. Let's sub in the origin. 0 minus 0, is that less than 4? Yes, so the origin's in the region again. So I'm going to be down that way. Combining my 3 bits of information up off that one, down and to the left, down and to the right. The required region you've just found, and it's pretty easy, isn't it? Inside that triangle there. Last thing they said was they wanted the coordinates of the intercepts. You could list them in a table, it'd be really nice, or you could just label them really clearly on your diagram. That has an x-coordinate of 1 and a y-coordinate of 6. This point here has an x-coordinate of 7 and a y-coordinate of 0. And finally, that point there, x-coordinate of negative 2 and y equals 0. We are done. Didn't take very long, did it? And that's with a lot of talking and going slow on the tablet. You will be able to do it at that speed comfortably. You just get comfortable doing the work. Remember to work under a little bit of time pressure when you're doing your homework. Just have a timer going. See how long it takes you. Write it down when you upload your notes. That way I'll be able to see and say, oh, I think you're taking too long. Try and work a little bit faster. Or you mustn't be understanding it correctly. Give me a look. Let me give you a hand. I will help you as best I can. All right, time for some sleep. Keep up the good work. I will see you back at school tomorrow. Cheers, guys. Bye.